This video is about graphing linear inequalities. So on the screen you see an example of what a linear inequality is. It looks almost like the equation of a line. In fact, instead of greater than or equal to, if you imagine that this said equal, the graph would be a line. And that's where we're going to start. So let's graph this as if it was just a line. The y-intercept is -4, so that's where we'll start. The slope is -4/5. So we'll count, let's see, if we go to the left 5 and then up 4, we'll have another point on the graph, and then we can graph the line. So if it was a linear equation, we would have graphed just by drawing the line like we've already done. However, because this is an inequality, we want all of the points that have a y value greater than the y value from the line. The way we indicate that is by shading the region above the line. Now I'm not going to try to fill this in nicely. We can just do some lines here that indicate that all of the points in this shaded region satisfy this inequality. So we have all of the points that are on the line as well as all of the points above the line, because we want all of the y's that are greater than the y values that you get on the line. So that's the basics. Let's see what happens in a different example. Here we have an equation that's not in slope-intercept form, so you have some preliminary work of solving for y. So let's do that. Subtract 2x from both sides, and then divide by -3. Now remember, when you multiply or divide by a negative number in an inequality, it changes the direction of the inequality symbol. So we're dividing by -3, so we have 2/3 x plus 1. -3 divided by -3 is +1. So now we're going to imagine graphing this line. Its y-intercept is 1. The slope is 2/3, so we can go to the right 3 and up 2. And maybe do that a couple of times to get a relatively nice graph. Now, I'm not going to draw a line here. What you want to think is, if this said equals, we'd have the equation of the line. This says y is less than. Unlike the previous problem where we had a greater than or equal to symbol, this does not say less than or equal to. It says strictly less than. So we don't actually want points on the line. If a point lies on the line that you would draw, you would have strict equality, and we only want y's less than. To indicate that graphically, what you do is you draw a dashed line or a dotted line, and this indicates that points on the line don't satisfy your inequality. And now we have to shade. However, this question is different. It says we want all of the points where the y value is less than what you get on the line. That means we shade everything below the line. So the shaded region, but not the points on the line, satisfy the inequality. Now, let's do one more example that's a special case. I like special cases in linear equations. So, if this said x equals 2, we know that that would be a vertical line. Since it says less than or equal to, we're not going to draw a dotted line again. We're going to draw a solid line, if I can get my pen to behave properly. So, we draw a vertical line, and now we have to shade a portion of the graph. Well, this says we want all of the x's with a value less than 2. So that would be on the left side of the line. So I would shade everything to the left of the line. And what we're saying here is any point in this shaded region, or any point on the line, since we drew a solid line instead of a dotted line, will satisfy the inequality. Anyway, that's how you graph linear inequalities. Hope that helps.